is a two-dimension elastic collision. Now, I'm not going to put a question like this on the test, but still going to walk you through how to solve it. So I'm actually going to walk through an already written out one. It's quite intensive. So again, because we have because elastic, we know that energy and momentum is conserved. So we're going to have to write down the equation for energy. Let's do that one first. So again, the equation for energy is E is equal, so kinetic energy is equal to 1/2 mv squared. So what ends up happening is that because each term has that 1/2, they cancel out. So we have that mv squared term, mv squared term, mv squared term, mv squared term, as you can see right here. So object A, 0.5, 4 meters per second. So we have 4 squared 16 divided times 0.5, we get 8 joules. Object B is not moving initially. And then after the collision, object A and B are both moving in some different directions. Again, because energy is scalar, I don't care about the angles. In this case, the angles alpha and beta. So I don't care about those angles. Okay, so just care that just what is the magnitude for energy. So you always check this one. So it's find out actually, actually you can, when I write out my energy equation, we end up with just one unknown, so we can actually solve it out. So in this case, I had B2 is equal to 4.47 meters per second. Now let's look at momentum. So because it's a 2D scenario, momentum there's momentum in both the x and y directions. So in the x direction, we have object A is moving to the right, object B is not moving, so there's zero momentum initially. But object after the collision, we need to find the cosine components. So cosine alpha, cosine beta. Same thing in the y direction. In the y direction, though, initially it's only traveling to the left or right, so we have nothing in the y direction. So we have zero momentum in the y direction, and something's moving up, something's moving down. So when I actually plug in the values, here's our equation 1. All I did is plug in the values. So when the mass was the 0.5 kilograms times 2, we get 2 is equal to 1 cos alpha plus 1.341 cos beta. In the y direction, we have 0 is equal to 1 sine alpha, but the other one's going down, so I get the minus. And now we have two equations again. Right, so all I did is move it to the equal sign. I move it to the other sides of the equal sign. So we have two equations. So the reason I'm not going to put this on a test is because you actually need to know some trigonometric identities in order to solve it. So in this case, what I'm using is I'm going to end up using I think it's the Pythagorean identity. I'll get to that in a second. So as they are right now, we can't really solve it. But from Math 12, we know that if there's like cos squared or sine squared, we can combine them in a lot more interesting ways. So I'm going to square both equations. So I end up with, on the left side, 2 minus cos alpha. I'm going to square that equation. So 2 squared is 4. I get minus 4 cos alpha plus cos squared alpha. On the right side, 1.341 cos beta squared. And we get that number. Same thing for the other equation, sine alpha squared, 1.341 sine beta squared. And we get those two equations. Now this is where the fun part comes in. If I now add those two equations together, we get the following. So I'll just add the two equations together. Let's see. So here's my first equation. Here's my second equation. We're going to add them together. So you have 4 minus 4 cos alpha plus cos 2 alpha, cos squared alpha, sine squared. But this is a trigonometric identity. Same thing. This is the same trigonometric identity. Right there. This is the Pythagorean identity. So this is equal to 1. This is equal to 1.798 because we factor out that 1.798, we're left with cos squared plus sine beta squared. And when that's just the Pythagorean density, so you got 1 and 1.78. So you move down, you get the exact same thing. So remember, cos squared plus sine squared is 1, and 1.798. Let's keep rearranging it. Now we just had let's rearrange our equations. So I subtract the 1, subtract the 4, we get negative 4 cos theta, divide by 4, inverse cos. We get alpha is 36.8 degrees and beta is 26.6 degrees.